Cool. So welcome all. I hope everyone's had a good week and weekend. What did everyone get up to? Anyone get up to anything special?
Bugger all, bro. Bugger all.
Fair enough. She sounds kind of relaxing, to be fair, doing not much. Oh, inside a Transformer today. Oh, okay. Did you take video? Sorry, I'm getting messaged by a bunch of people offline, so I'm just having to mute that. You say nothing too interesting, but I've never climbed inside a transformer or measured the output sheath. That sounds funny coming out of my mouth. Um, but yeah, just remember, guys, just because you think something is kind of boring and everyday in your field, it might be something interesting to someone else. Like the idea of all the high voltage stuff, because I've never got to play with it, sounds interesting to me. But wiring up a house, I've been there, done that. It's all about perspective. Speaking of which, I'm going to share screen and then I'm going to start. Okay, can everyone see the lovely background there? And you should be able to see. Cool. So tonight we are going to start talking about industry governance and legislation. Big wordy kind of topic. But first things first, we are going to start with a little bit of revision. Cool. So what is circuit discrimination and why is it important? Decommissioning, sorry. What is circuit decommissioning and why is it important? Yeah, that's what it's for. Yeah, safe removal of electrical fittings or equipment. Yes. I wouldn't say no chance, but definitely less chance. Yeah, it's good for safe maintenance and removal, keeps us safe. Yeah. Yeah, I'll start talking, but definitely keep the answers rolling in because it's good for you guys to just keep the chat up so I can make sure you guys get marked present. Cool. So decommissioning is the safe removal or isolation of electrical equipment while ensuring that exposed energy sources remain safe. So the important word there is energy sources. It's not just talking about electrical sources. It could be pneumatic, pressurized air. It could be hydraulic, pressurized liquid. It could just be normal hot water. It could be steam. It could be mechanical, a weight suspended from a high load or tension, where something's under tension and all of a sudden it might release tension and shoot out. Cool. So this process follows the lockout tagout or LOTO procedures to prevent accidental energization. ASNZS 3000 Section 8, if you guys want to have a look at it, and ASNZS 4836 provide key guidelines for safe decommissioning. And just remember, guys, if you are able to log into the EWRB portal, part of your registration, the costs that you pay gives us access to Standards New Zealand, where you can view all of the related legislation for our industry online. And when you go to view it as a PDF, most of the time it will then download it for free for you. You do have to pay if you want a printed copy though, and they're not cheap. Cool. So what is the prove, test, prove method? To the last question, that's a good one, Connor. The target circuit of component is disconnected. So the two standards, you've got AS/NZS 3000 Section 8, which is the wiring rules, and then you've got AS/NZS 4836, which provide key guidelines for safe decommissioning. I like that. Prove you didn't break your meter. Yep. Yep, so you guys are getting it. Yep, so yeah, prove the tester is working on a known live source, test the circuit to ensure it's de-energized, and then the correct terminology is prove the tester again on a known live source, but I like the term of prove you didn't break it while you were doing your testing. Cool, so recommissioning process and key tests. So I'll just go through this. So after decommissioning circuits, we must test before re-energizing. AS/NZS 3017 verification and testing, and AS/NZS 3760 testing and tagging outline key tests. So you got your insulation resistance test or your IR test to ensure wiring insulation is intact. Your earth continuity test confirms a safe path to earth, and your polarity test, which ensures active, neutral, and earth conductors are correctly connected. And the equipment must be fully tested and documented before being put back into service. So 3017, so that's all about verification and testing. It's a supplement to Section 8. And then AS/NZS 3760 is testing and tagging of in-service appliances and machinery. So why is lockout tagout so important? Hmm. Those are all really good answers, guys. So yeah, the main point of lockout tagout is to ensure that the person who locks it out and tags it out is the person who can then remove that lockout and tag. Um, so it ensures circuits can't be accidentally re-energized while we're working on them. Proper lockout devices and warning tags must be used. And common mistake is removing a lock tag before verifying all work is complete, which is why I prefer on bigger lockout tagout jobs, you have a lockout tagout supervisor. And so when you lock out a source of energy, you put a multi-lock on it and everyone is working on it and the supervisor puts a lock on it. That way the supervisor's lock is the last one to be removed. So that way the machine can't be turned on until he's talked to every single person and said, yep, my job's done. Yep, everything's ready to go. And it's not a case of, oh, I forgot to do one thing. Just let me quickly go back and do it. Because that's the worst thing that could happen. They're trying to work on it, and all of a sudden, machine turns on, things start spinning. One of the more horrific ones that I can, it's not so much lockout tagout, but I was told a story of there was a lumber mill where they had I think it was a debarking machine. There was an issue and log jam, so worker went into the machine and hit a emergency stop that was supposed to make sure the machine didn't turn back on again, and then went into the machine to dislodge the jam. Someone came into the control room, saw the machine was stopped, couldn't see her, and started the machine. It's a story I was told. I don't know. I didn't look into it because I didn't really want to know all the gruesome details. But suffice to say, I don't. You used to work there. Do you know the story? And is it true? Fuck. That's what I thought. Yeah. So yeah, guys, that's why we need to make sure our safety procedures, lockout, tag out, and all of that are in place. And we need to make sure if you're doing control work on machinery, that your control work is done in the correct order. Um, so that way we don't have incidents like that. Cool. So why is documentation important when we do these kinds of things? So why do we need to document everything? I like that one, that everyone's on the same page. Yeah, stands up to standards and is safe. Yeah, it lets you catch things early in the planning. Yeah. Yeah, nothing's left undone. Every box is ticked. Yeah, so a lot of guys do think that documentation is ass covering. I would agree on some things that are a little bit over the top, but when it comes to things like lockout, tag out, it's the records that need to be kept of the decommissioning, recommissioning, and testing, and they ensure compliance with the electrical safety regs and the certificates like the COC, ESC, and ROI confirm that the work is done safely and to a standard. But also a lot of the lockout tag out documentation, if you're reading over what was done previously, it lets you know what order you should be doing things. And so even though you've been trained on lockout tag out before, you're looking at what people have previously done. You're like, oh yeah, I remember I've got to do this, I've got to do that. And sometimes you go, oh, I forgot about that. I need to do that as well. So it is also a good way to do things like that. Cool. So why is it important to follow the prove test prove method when decommissioning electrical equipment? Yeah, so the main reasons are it's a way for us to ensure the circuit is completely de-energized before work begins and prevents false readings due to faulty testers or incorrect assumptions. Sometimes, even though you've isolated the circuit, there still will be some residual voltage, especially if other machines are connected. So when we do lockout tag out here in the workshop with the pre-trade students, they'll get 230 volts, but as soon as they flick the circuit breaker off, they'll still be getting about 4 volts until I turn the an actual isolator at the start before the main switch, and then there's zero. So just sometimes because there's other machines running, it will induce a small voltage. Cool. So three key electrical safety tests you should perform before recommissioning a circuit. So that's your insulation resistance test, your earth continuity test, and your polarity test. So you always need to do your IR test, earth continuity, and polarity. If you don't do any other tests, you should always do those three. So what are two key safety rules for lockout tagout procedures? Yeah, guys, these are all some really good answers. So the two big key things for lockout tagout is you guys are kind of worked around it, only the person who applied the lockout tag should remove it. All good, Levi. We're just doing some revision and you can watch the revision later on the video. So yeah, only the person who applied the lockout tag should remove it. Yeah. So you should always have your key on you for that lock and always verify isolation before you work on the equipment. So even though you've locked it out, you should verify the isolation. And someone said 1 key, 1 lock. Sometimes it's 1 key, 10 locks. So you'll have 1 key, but you'll have 10 locks for that fit that key. So you can lock out 10 different items. So that way you can, one person can, if the machinery has 10 things that need to be locked off, you can lock off all of those 10 things. Otherwise, you're constantly trying to find the key for that particular lock. Most of the time, unless you special order them, the locks will only come with 1 key anyway. But you can order keys and locks that are the same. Like all the padlocks for the isolators we use here in the training center all have the same key because the tutors need to be able to unlock all the different types of equipment that we use here. So why is documentation important when decommissioning or recommissioning? Because it confirms the circuit was safely isolated, tested, and restored. It ensures compliance with AS/NZS 3000, AS/NZS 3017, and the electrical safety regulations. And it provides a record of safety checks to prevent liability issues. Cool. So yeah, safe decommissioning and recommissioning relies on proper testing and documentation, as well as proper training. So some workplaces will put you through retraining on lockout tagout, especially if you mess up, you will be sent for retraining. So understanding in the industry standards, so like 3000, 3760, 4836 are key to compliance. So that's why as you go through all your years of doing your apprenticeship, so year 1, we're talking about legislation. You'll talk about some more in year 2, and then in year 3, you'll do the full-on regulations course where you'll study the regulations for 6 months before you sit your regulations exam. Cool. Now we're going to look at the industry governance bodies that we have. So before we get into the specific documents that we follow, we'll look at who makes the rules, who enforces them, and who manages safety, the different industry bodies, and who each of them play a role in keeping workers and public safe. Cool. So the Electrical Workers Registration Board. So what do they do? So they're in charge of issuing licenses to electricians and other electrical workers. They set qualifications and competency requirements to make sure those who are working in the electrical industry are competent. And they handle complaints and disciplinary actions for non-compliant electrical workers. So can you guys name any of the things you've heard of people being disciplined for by the EWRB? Yep, the Nelson extractor fan. Yep, that's a big one. Yeah. So one of the things you'll hear, sometimes it seems like it, or maybe 2 people that have brain cells. I shouldn't have said that out loud. But no, there are quite a few people who work for the EWRB. It's just that, yeah, a lot of the systems were not optimized early on. It does take time. Yeah, so that range hood, that was Nelson. So one thing you'll see if you look at the Electron newsletter about some of the disciplinary hearings is you'll read about filing a false return. So when they say filing a false return, what they're talking about is they did a cashy job, is they did a job without filing, basically without paying tax, without paying GST or anything like that. So when they say false return, that's what that means. So that's more of the acknowledging there was an IRD issue as well. So usually it only comes up that they filed a false return if they do it too often or if they get taken before the EWRB. So moving on, My favorite organization, WorkSafe, the Energy Safety Division. So what do they do? Their role is to enforce the electrical safety regulations, or ESRs. They investigate electrical safety incidents and enforce corrective actions, and they provide safety guidance to the industry. So they'll publish guides in their gazette to allow for people to improve their electrical safety. Cool. You got the Ministry of Business, Innovation and Employment, or MBIE. ESR is for electrical safety regulations. So we'll talk about the different layers, but the electrical safety regulations are one of the documents that we have to learn about. So what do MB do? So they develop and oversee New Zealand's building and electrical safety regulations. So they're in charge of overseeing the regulations. Basically they deal with how people do business, they innovate new ways to do things and deal with employment issues. So they ensure the regulations stay up to date with industry needs, although there's a lot of grumbling within the industry that they're not doing a very good job of that lately, considering we're still working on the wiring rules from 2007, whereas Australia has been on 2018 for a while, and it looks like there's possibly going to be a 2025 or 2026 coming up soon, depending if they can figure it out. Cool. Then you've got the Electrical Engineers Association. So they're an industry-led organization providing technical guidance, and they develop best practice recommendations for the supply industry. So they're the ones who spend a lot of time consulting on the way we design our PowerPoint, switch gear, and the materials that we use in everyday electrical work. You have the New Zealand Electrical Inspectors Association, or NZEIA. So they represent and support registered electrical inspectors across New Zealand, and they provide a network and technical guidance and training opportunities. So if you ask an electrical inspector a question and he doesn't know, he's either going to go back to someone like Master Electricians, or they're going to fire it into the NZEIA, and they will be able to get you an answer as to exactly what you should be doing in the certain situation. Cool. And then you have Master Electricians, or ME. So they represent electrical contractors, and they provide industry support, training, accreditation, and the Master Electricians guarantee for quality assurance. So they're really good guys. We have the office for the Wellington branch literally on the same floor as us here, and so oftentimes they'll have discussions with us. We'll have discussions with them about what's going on in the industry and some of the weird things that we have apprentices come and tell us and ask us. And then you have ASPEC. So ASPEC are people. Yeah, that's fine, Blake. Maybe try leaving and rejoining the meeting. See if that works. Otherwise, that's fine. So yeah, ASPEC. So what do? So they deliver examinations for electrical workers on behalf of the EWRB, and they're responsible for managing exam schedules, delivery, and assessments. So eventually you will have to deal with ASPEC. You will have to become ASPEC registered, because they are the ones who you'll be sitting your exam through. So what happens is you sign up with them, you book your exam, or possibly ECHO will book it for you. And so you'll go along to their place, and there'll be a bunch of computers set up in groups of 3 facing inwards. So you won't be looking directly at anyone else's screen. And then you'll be doing your exam on a computer-based system. They are able to open up extra slots. So if you want to sit your exam in, say, December, and for some reason all the slots in your area are full, you can email them saying, hey, I really need to do my exam in December, and they'll try and open another slot for you, because it won't just be electricians sitting the exam when you do. You'll have electricians, aircraft engineers, plumbers, midwives. They do exams for a lot of different organizations. Cool. So now that we know who makes the rules, so we'll look at the actual documents electricians follow in our work. Every electrical worker needs to know what standards and regulations exist, where to find them, and which ones are legally enforceable. There's a hierarchy to these standards and regulations, but we'll cover that next week. So key documents used in electrical work and where to access them. So you've got the Electricity Act 1992. So it establishes the legal framework for electrical safety and gives WorkSafe NZ the power to enforce safety regulations. So you can find that at www.legislation.gov.nz. It is very, very dry reading. But yeah, again, it is free because it's an act. It's not a standard. It is an act, so it is free when you go to the legislation.gov.nz. It is very dry reading, but you will need to learn how to use it. And when you, if you ever decide to go for your inspectors, you will need to know it a lot more. Cool. So then we've got the electrical safety regulations, or commonly 2010, commonly known as the ESRs. So these define what is legally required for electrical safety in New Zealand. So it categorizes work into low, general, and high risk. And you again can find that at legislation.gov.nz. This again should be free because it is a safety regulation. And then you've got the ASNZS standards. So these define what is legally required for electrical safety in New Zealand, and they categorize work into low, general, and high risk. So you've got a few different ones. So you've got the ASNZS 3000 wiring rules. This is a mandatory document, but in it, they will have different terms. Like if they use the term shall, it means that you have to do it. If they use the term should, it's considered best practice, but you should always be aiming for that best practice or better. That's just my opinion. And then you got ASNZS 3008.1.2. This is the current carrying capacity of cables. When you're looking at 3008, make sure it's 0.1.2 because 0.1.1 is for Australia. Obviously, they've got different levels of heat and moisture, so different current carrying capacities. You've got ASNZS 3017, verification and testing of electrical installations. ASNZS 3760, which is in-service safety testing and tagging of electrical equipment. And then you've got ASNZS 5761 and 5762, safety of electrical appliances. So these could be accessed through standards.govt.nz. It's a subscription required. However, if you can access the EWRB portal, you should be able to go to the standards portal from there and be able to download them for free. And then you've got the Electrical Codes of Practice, or NZECPs. These provide additional best practices for specific installations. So some of them, though, are legally required if referenced in the regulations. So this one there, New Zealand Electrical Code or Practice for Homeowner Occupies Electrical Wiring Work in Domestic Installations. So as one example, NZECP 54 covers electrical installation in dairy sheds. These can be accessed through WorkSafe NZ. So applying the documents. A client has asked an electrician to install a new circuit for an EV charger in their home. This involves new wiring, circuit protection, and ensuring compliance with all the regulations. So the documents that need to supply with this job. So the ESRs, what ESRs apply, what standards are relevant, and are there any NZECP guides apply? So legal requirements for the electrician to follow. So you need to follow the ESRs 2010. This job will involve installing a new circuit, so it falls under general risk prescribed electrical work as per regulation 64. Oh, sorry, 6A. A certificate of compliance is required and an electrical safety certificate must be issued. So to find more information about cable sizing, protection and installing methods, we would need to reference AS/NZS 3000, the wiring rules. So that'll cover installation methods, circuit protection and compliance requirements. And then we'll look at 3008.1.2, and this will tell us the correct cable size based on load and installation conditions. You can use this, or you can use any of the free apps like GenCalc. GenCalc is available offline, so if you do download it, it will still work when you don't have service. And then, so this job would require a COC, a certificate of compliance, for any new installation work. An ESC confirms the installation is safe to connect to a supply. And then an ROI, the record of inspection is not required because this is not classified as high risk electrical work, so an inspector is not needed. So why is it important to know where to access electrical standards? So GenCalc is just for current carrying capacity, whereas 3000 is actually the wiring rules. You can also use the Nexans one. The Nexans one's usually pretty accurate. Yeah, there's a ton of paperwork, that's for sure. So how would not knowing this information affect an electrician's ability to do their job? Yep. So if you were unsure about an installation method, where would you check first? Yeah. So first port of call would be 3000 if it's an installation method. And then if you can't find anything in 3000, then you'd be looking at ECPs or manufacturer's instructions. And then you would ensure that on the COC you would write work relies on manufacturer's instructions and attach the manufacturer's instructions to the COC. Cool. So scenarios. So serious electrical shock incident occurs on a job site. Who's involved? What documents apply, and why? So what industry bodies get involved if someone has an electric shock on a job site? Definitely. Yeah. So WorkSafe gets involved. So what documents would apply to this? Essentially, the EWOB, yep, that's what happens after the investigation, though. WorkSafe would be the first one to get involved in the incident. So what documents apply? And when we're talking about standards, what documents would apply? Yes, you'd have to do an incident report, but what kind of documents in terms of the standards, regulations, all ECPs, all that kind of thing, what documents do you think apply to this? Act? Honestly, it's not so much the act as it is the safety regulations, 2010 ESRs, especially the sections on incident notification and safety obligation. So so it talks about incident notification and safety obligations. So why are WorkSafe getting involved, and why are the ESRs applied? Okay, so the reason WorkSafe get involved and the ESRs apply. So WorkSafe NZ is responsible for investigating serious harm incidents under ESRs. So they're responsible because of the ESRs, and the electrical incidents causing serious injury must be reported to them. The ESRs outline the legal duty to notify and the corrective actions required. Cool. So scenario 2, an apprentice is unsure about cable sizes for a new residential circuit installation. So who's involved in this in terms of government? You could go to the NZDIA. Supervisor. Good call. Great one, Tim. Etco. Oh, I hope we're not involved with this. Cool. So in terms of governance, there's no specific governance body directly, but EWRB expects all licensed workers to comply with the regulations and standards. But yeah, so Google, ask Echo Tutor, ask Master Electricians, ask an inspector, Snapchat AI. Okay, so what documents apply to this about cable sizes for a new residential circuit installation? What documents apply? Just remember, guys, the letters AZN, ASNZS, basically just means Australian New Zealand standard. So Australian standard, New Zealand standard. It just means that we share the standard and that they apply to both sides of the ditch. But yeah, so yeah. AS NZS 3000 wiring rules for installation design and requirements, and 3008.1.2 for current carrying capacities of cables. So why? Why do these two documents apply? Okay, Tim. Tim's the rules. Yeah, basically, AS/NZS 3000 outlines the basic wiring rules, including how cables must be installed safely. And then 3008.1.2 provides detailed tables to ensure cables are sized correctly for the load and conditions, preventing overheating or voltage drop. Cool. So an electrician's license has lapsed and they need to renew it. Who is involved? Yep. Pretty much everyone hit the nail on the head straight away. The Electrical Workers Registration Board, or EWRB. Boss, wife, maybe? Yep, cool. What documents apply? An application form, definitely. Application of renewal, yeah. Yes, competency. That's a good one. So yeah, if your license is lapsed, depending on how long it's been, it could be just a simple renewal form, or but you'll also have to go for a competency course. So they have rules and competency requirements, which are found on the website. So who knows how many times how often do we need to renew our license? And what do we need to do before we renew our license? I wish it was 5 years. It is 2 years, but yeah, and we need to do a competency course. Yeah. So every 2 years, we need to do a competency course in first aid. And we are the only trade that requires a first aid as part of their license. I think it should be all trades who are licensed. So the competency course, so basically you arrive, you chat, you talk about any changes in the legislation, so any new rules that have been brought in, any rules that have been deleted because they're now obsolete, and then talk about they usually have like a standard or a topic of the course, and you'll go over that. Then you'll go over testing requirements, make sure we all understand what tests are required, and then you need to demonstrate your testing. So basically, you get given a competency panel. It's got a whole bunch of things on it that have faults, and you've got to test it to find the faults. And once you find the fault, you can flick a switch to get rid of it. Find the next fault, flick a switch to get rid of it. And that's how we do them here. And then you do your first aid. So your CPR, resuscitation. Yes, it is really boring. I've only done one. It was at Site Safe, and someone managed to mega himself, and what was really embarrassing. Cool. So why do the EWB need to be involved, and why do they have rules and competency requirements? If you're doing your apprenticeship, you won't have to do a competency course until after you get qualified, so long as you don't let your registration lapse. Make sure they still know what they're doing. Yes, yes. Muppets are hamstrung. Okay. Yep. To ensure people are competent. Yep. Yep. Yeah. Especially if you're doing stuff like solar, you really need to be up on the rules for that stuff. Cool. So yeah. So the EWRB handles licensing for all electrical workers. They set competency standards and require regular renewals to ensure electricians remain qualified and competent to work safely. So we'll just do a couple more. So scenario 4, an electrician is asked to install an electric fence on a rural property. Who's involved? Yeah, you would. Yeah, so the WorkSafe is a possible party involved because they enforce they're the enforcement body for electrical installations. And then you've got the EWRB if work requires a licensed person. Cool. So I'll go over the documents. So the documents that apply, you've got NZECP 25, electrical installations for electric fences, and then you've got the safety regulations 2010 ESRs. So this one's a bit of a complicated one because it's not always straightforward. And so the reason why, so NZECP 25 provides the specific requirements for installing electric fences, including safety distances and warning signage. WorkSafe enforces the rules around electrical codes of practice, and ESRs make it legally enforceable by referencing this ECP in the regulation. So inside the ESRs, they do make reference to this specific New Zealand electrical code of practice. And that's something you guys wouldn't really know about until you have studied the ESRs as much as third year or even possibly a inspector. Or you would look through these going, I'm going to install an electric fence. What the F do I need to look at before I do it? So even when you're an electrician, sometimes you're like, you get asked to do a job that you've never done before. And so you have to go back and double check your knowledge. Cool. So new building regulations require updates to electrical installation practices in earthquake prone areas. Who's involved with the new building regulations required? So it's a building regulation. Yeah, Sasha's got it. So yeah, MBIE, so the Ministry of Business and Innovation and Employment, because they are in charge of developing regulations. So if it's a new regulation, MBIE's usually had a hand in it. Cool. So what documents apply? So what pieces of legislation? Yep, it's a good one, Connor. Building code. a couple others as well, at least one more. So yeah, building code. I believe the earthquake standards fall under building code. Um, but yeah, there would be an update to the building code and one other. Yep. Yeah. So yep. So there would be any updates to AS NZS 3000 or NZ ECPs as they relate to installation practices. I believe there is a NZ ECP for earthquake and earthquake prone buildings. Um, One interesting one to be aware of if you're working in a building that has base isolators, so like Te Papa or the one Andy and I did at Wakefield Hospital. Anytime you cross the seismic plane, because the foundation and the floors above are separated at a point, and they have rubber base isolators that will shift and move, you need to allow slack in the cable for that seismic shift when you transition from one seismic plane to another. Because if they move and your cable is tight, at one point it may jarringly shock away from where the cable is run from and run to, and then it'll yank on that cable and either break it or stretch it, which is quite an amazing sight to see. Oh, nice, cool. Yeah, so yeah, real world situations. Cool. So why are MB involved in the building code and any updates 3000? So the reason MBIE and those ones, yep, so it's documented, yep. So yeah, the reason MBIE gets involved with new building regulations is because they set building and construction regulations in New Zealand. So anytime we need a new regulation, they're the ones who are involved with that process. If new rules are introduced for earthquake prone areas, they will update the building code and possibly influence requirements in AS/NZS 3000. Electricians must follow these updates to remain compliant. So yeah, if they make updates to 3000, they'll usually issue what's called an amendment. So AS/NZS 3000, 2007, I think currently has two amendments for it, which relate to various changes to safety documentation. Okay, guys, that's the end of the PowerPoint. I am going to stop sharing the screen. Cool. So I will also, because we are finished with the study portion, stop recording.